Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Paper number 2 today, a celebrity, the first ever Jim Gray Award winner. Dr. Carol Goebel will be talking about a biocatalog.
Thank you. I have my So I'm going to talk to you about a project that's only just started. So my experiment's been running for quite a while. But my experiment inspired this project, and in fact we're leveraging a great deal of the code base developed in my experiment on the Biocatalogue. So this is a joint work with the European Bioinformatics Institute and Manchester, and what we're building is a catalogue for web services for the life science community. So to set this in context, web services, and this is a web service session, in the life sciences has really seen a bit of an increase in footprint in the community. So, for example, the European Bioinformatics Institute, based at Hingston in Cambridge, now has 3 million monthly accesses to its services through web services rather than through the web. So it used to be web interfaces that people just sat at and clicked on, and now it's increasingly through applications. We guesstimate, we did an educated guesstimate, there's between 1,000 and 1,500 web services that are available, that are readily available to the bioinformatics community. So why has this happened? Well, because there's been a kind of systematic attempt to take monolithic servers and to break them up into web services specific functions, so that they aren't just large monolithic applications anymore, because people who are building new services know that this is the way they should publish data, so they've begun to do that, and also because there's an increasing number of automated life science applications, like workflow systems, like all the workflow systems we've been hearing about, which execute web services. So there's this growth. The web services fall into two classes, really, from the community point of view. They're from chain stores and boutiques. So the very large data centers and national centers are all making their things available as web services, their data and their tools, like the EBI and PDBJ and in Japan, and NCBI in the US. And then there's investigator and community projects. And these are smaller efforts where basically the results of the projects generate some data sets. They expose them as web services because they think that's a good idea. These web services are often very unreliable and badly designed, because the first major data centers understand about load balancing and other things like this, and the smaller projects don't necessarily. But there's a hell of a lot of them. There's a long tail of these available. They're also very unstable in the sense of many of these run for a bit and then die or disappear, or have very poor sustainability stewardship associated with them. So this is a schematic from a Nature article about 2 years ago that said that well over 50%, or 50% were shutting down due to lack of funds or struggling financially. So you can use a service and then it disappears. They're also of multiple flavors. So there's SOAP and there's REST, and REST is really rocking. The life sciences love their REST services. And then there's quite specialist web services, like the distributed annotation service from Cold Harper Lab, and also the EBI, which is a particular kind of web service, and Biomobi, who Mr. Biomobi is sitting here, Mark Wilkinson, which again is a web service, but it's a particular kind of web service. It has particular constraints of how you use it, or how you should use it. So that's cool, there's all these web services. Then you go to try to use them in the wild, what happens? Well, first of all, you've got to find them, and it's not always easy. So, for example, from the Emboss suite, which is a widely used suite, ran out of the EBI, the Cluster W multiple sequence alignment program is called Emma. Well, why would you think that? But this is a community that calls, its gene Sonic Hedgehog and other names like that. So they have all these fun names. But this is very difficult to identify and find out what these services actually do. And so finding them's hard, and that means they're invisible. That means they have poor adoption by their providers. They don't get adopted very well because they don't have a forum for advertising and shopping and finding these things. And also the people who would like to use them can't find them, so they reinvent. Also, executing them is pretty tough. The whole idea of are these executable or not. There's WSDL, there's the REST ones, will be coming WSDL 2. But there are other kinds of services that are harder to understand how to execute because they're quite specialist. And we needed a way of describing those services that transcended the specific grounding, so they weren't just assumed that they were just WSDL services. Are they understandable? Well, no, they're not. Input 0 string, output 0 string is the most common signature of a web service that's in the wild, which isn't very helpful. What does the input mean? What does the output mean? What does the string mean? What does something like secret actually do? Well, that's actually a challenging thing. They don't provide examples, they don't provide example data, they don't provide configurations, example configurations, they don't provide input-output correlations, terrible documentation, so it's almost impossible to do anonymous reuse of these things. And are they actually usable and available? So what's the quality of service? Are they stable? So Biomart, which is a very popular service that's used widely, changed its interface, its API last year 4 times, just because it could. So it's and it breaks all the systems that use it. Are there licensing or execution restrictions? You can only use this service 200 times in a 24-hour period, say, that sort of thing. So we need monitoring and intelligence gathering. So are there catalogues already? Well, yes, there are. There are catalogues that are specific to a particular project or investigator. So, for example, the Embrace project or the Biosapien project built their own list of their services that they built in their project, and they produced a catalogue for those. There are community lists that people do out of heroic concern for the rest of the community, and these tend to be lists of web links, effectively. There are project specialist registries like the Biomobi Central Registry or the DAS Registry or my own project, the MyGrid Registry, but they're really designed for their projects. And there's general catalogues, which are very general catalogues, like the SIGDA service, which are, they cover SIGDA currently covers 27,000 web services, so it's not very specialist at all. So the issues that happen are, well, sustainability and curation, particularly for the community and the investigator ones, but are they accessible? Do they have rich annotation? And is it customized to the life sciences? And do you have real provider engagement? So SIGDA, for example, builds no relationship with the providers. It just goes and scavenges the services and does the best that it can. And that's not appropriate. So what we thought is we'll pool our knowledge. So we'll build a reliable, trusted, up-to-date and sustained catalogue that's customized for life sciences that would have EBI's sort of stamp of approval behind it from the curation process, because that's what it does. The EBI curates large-scale databases, so it understands the notion of curation, and there'll be a service commitment. That we build a discovery interface for decision support, so you'll be able to choose your services, drawing on the MyExperiment and our EBI legacies. That we would do real curation. We would pay curators to sit there and curate these services, and we would also accumulate curation through the community. And we'd build it for a platform for service monitoring. We'd also follow the MyExperiment role of incorporating this into applications and mashups by making it also a web service that would have a REST API that follows the MyExperiment game. So the project just started. It started in June. It's in closed pilot. It's just entered closed pilot phase with only friends. And in order to be able to do this very rapid interface development now, which Dave mentioned, it goes for a pilot release in April. And if you want to become a friend, you could come and talk to us. It's a 3-year reward in the first instance, but then there's a long-term commitment. So the influences are, as you've heard, MyExperiment for the social curation aspect. Things like service providers. So we want to be able to say this service is compared to that service. So we looked at things like broadband providers and other, people compare and contrast to go and look at other kinds of services. like the US Department of Health and Human Services compare your hospital services, which I found quite interesting. You can find out all about how hospitals are failing in Indianapolis. Right, anyway, so I had a look at that. But these are kind of comparison sites. And also shoe shopping sites. This is very important because I think it should be as easy to use this environment as it is to go shopping. So we looked at all of these different sites as our influences. So we built a profile, service profile wheel, which is, describes our underlying model that we're collecting information on at the moment. So we have, here's our facets. We have 6 facets. The functional capabilities, what the inputs and outputs are and so on, what does it do? Operational capabilities, how do you actually run it? So those are the kind of 2 that are classically represented when people are describing services, but also things like the social standing, so collecting information about what's the popularity, how often do people download or look at a service, are they using them in workflows, a provenance, where did it come from, and the use policy. Does it require licensing? Does it require money? Do you have to be a member of some sort of organisation to use it? And operational metrics, like what's the quality of service? And that means the content draws on 2 classes, the content for each of these facets. Semantic content, which we use for describing the functional characteristics, and also things like the provenance and use policies, and quantitative content, the statistical analysis, which fills out operational metrics, but also social standing, because you build up a pattern of use. And around this is a curation model. So the curation model is who said what when, including versioning, because these services version all the time, and they also have multiple deployments. So what we have is that we have a system where we're monitoring and validating our services, that we can draw upon things like My Experiment, and by plugging in other monitors from other applications, which is part of our program of work, we can gather analytical information. We can use this as part of a sorting and ranking information, so which we are making as a separate pluggable component, so it can be customized, and then we can do discovery. The point here is that we're trying to avoid any kind of binding or grounding to a particular class of service. So this isn't, we're not using SourceStore because we have all these REST services, and we don't believe SourceStore is an appropriate description for describing REST particularly well. So instead, what we do is have a completely abstract grounding independent model, which we can parse in, and we bring in other descriptions, and we can spit out, we can generate results. So if you want a SourceStore version, we'll send you a SourceStore version. You can access it, but that isn't the native way that we describe things. The modeling, I come from a semantic community, as some of you may have heard yesterday, and there's been a huge amount of effort on semantic annotation of web services. Semantic web services were the great hope of the semantic web before we discovered the data web and stopped doing that. And they've never been that brilliantly successful. So here's Wismo is one of the very well-known semantic web techniques for describing services. SourceStore is a more adopted one, but not hugely adopted. OWLS is a very complicated system. And the reason is because many of these were describing the functional signatures, what does it do, what are its inputs and outputs, with a view to doing automated composition and decision making, not decision support. So they were trying to do automated service composition. But actually discovery requires much less effort. So you can describe things, if you're describing them for people, without having to get bogged down in complicated ontologies. But just describing things using a few tags is insufficient for making them useful, because then you have to describe much more in order to be able to reuse effectively, because you have to be palpable, i.e. you have to describe what does it really do, what does it really mean, so I can understand it. So we're bearing in mind this thing that says, okay, we could spend a lot of time doing very fancy ontology descriptions for not, and we'll get a lot of pain and a lot of gain, but it's probably not worth it. We're going to stick around here when we're doing our first efforts. So our first efforts are going to be based on tagging and importing what we've done in the MyGrid project on ontology annotation, but we're not going to go and spend long hours getting ontology stuff done. Okay, I have to speed up. Okay, so the ontology that we are using is the MyGrid ontology that we've been using for years, which describes, again, follows this kind of feature. It says that there's a service features, which is the services, the operations, inputs, outputs, tasks, methods, and resources. And then it has a domain ontology, which is the formats, the tasks, molecular biology, and so on. So it separates out these two aspects, the functional part. Note the term operations. Actually, people don't really want services annotated. They want operations of services annotated, because it's the operations that you're really, really doing. Okay, so I'll skip over that. That's how we used to do it. But the take-home there is free text and tagging in the user's language and smart interfaces go a long way. But richly semantic annotated services will be used for driving interfaces and automated processing, but we really don't want to neglect this piece. People tend to neglect that piece and get all excited about the semantic annotations. So briefly, we're adopting my experiments ideas of curation, social curation and social input. So I have to whiz through this. We're going to promote the whole notion of people-powered registration, so that we're building environments so that a provider or a proxy for a provider can register a service, and that raises serious issues of ownership. So if somebody's registered a service on behalf of the owner can deregister it, because they may not want it registered, or they may want it re-registered in a different way. There is the whole issue of how do we incentivize people? How do we get complete metadata? Because the added value of this catalogue over and above other catalogues is the quality of the annotation, the quality and completeness of the metadata. And kind of one of the incentives is, of course, visibility and reputation, but reputation cuts both ways, because if your reputation plummets because your service isn't very good, that's not always flattering. So there are issues there to do with, which we'll have to deal with, I think, far more than we'll have to deal with in my experiment. And we also presume that providers will be unhelpful, and actually that's not the case. I think providers will be very helpful. We're also doing people-powered curation, both third-party and provider curation. Here we learned from my experiment that the way to get real curation, to get real tags, tagging, and metadata is not on the website, but going to the website. It's through the applications that are actually using the services. So we have to, therefore, gather curation environments and metadata via third-party applications. So we're going to have to develop mechanisms of being able to do that, because people don't want to come back and say about a service. They want to be able to say, this service doesn't work in the application that they're actually, or I like it in the application that they're actually working on at the time. Of course, our model has to be deeply incremental and our partial descriptions. And there are issues to do with peer review, as just been raised, that the wisdom of the crowd is, well, we have to see how that's going to go. Oh yes, so the best way to get people to do things is to promise them presence. And we learned from NanoHub that the best way to get people to, when NanoHub did a competition for curation, they made tremendous inroads, and Mark's also found this in the Biomobi world. And the biggest thing people will sit and tag things for hours and hours and hours are T-shirts. So T-shirts really rock. So you can have annotation jamborees for T-shirts. And so another rich part of the Biocatalogue activity is we're actually funded to do expert curation. We have full-time curators who will be, so this is a real added value, that can give some of that quality assurance and trust and write those really enriched annotations that we may want in order to be able to do more automated or sophisticated processing. But for that, we have to build some sort of curation pipeline that moves things that have been just tagged to things that are tagged with ontologies, to mine the tag clouds in order to be able to generate the ontologies, and to do ontology husbandry, and that's non-trivial. And effectively, as Denise would say, we have a sweatshop here. And how do we make this smarter? Because you can really burn out curators. Curators the EBI rotates an awful lot of curators because it's a deathly job to do. It really kills you. So I'll have to skip over this in the interest of time. Which was the annotation model. The ranking, sorting, filtering, and comparing. Here we have, we also stole mercilessly from the CA Big project here that they have a kind of bronze to platinum kind of compatibility regime. So we're having a bronze to platinum regime of quality and quantity of metadata. Particularly for the things that represent usability, which is the operational metrics and the social standing and the provenance, and is this useful and is this usable? This is the questions that people ask, and they use these measures in order to be able to make those decisions. And is it understandable? They use the operational and the functional, but actually make decisions of which service to use based on these features and not on these features. Okay, so they just say, okay, I just want a blast service, so they get 12 blast services. Which ones do they choose out of that? Because they're all pretty well the same. What we didn't want to do was to do a ranking that said this one's more important than that one. That would be lethal, because the community cannot decide on what is a relative ranking. So instead, we're going to present information, and then the users decide, as it were. So these are examples of prototype systems that we're leveraging. This is from Embrace. There's a traffic light system that says whether the service is currently up or not. This is kind of the being notified that things are changing from my experiment, so you can see what's the activity around a service. You can get graphs about uptimes. From SIGDA, they give indications here of what related searches, being able to sort things based on available documentation. So if there's lots of documentation, that gives you a higher thing to be sorted on, and so on. So these are all ideas that were going into us. So I mentioned that there was a lot of manual curation, but of course we need to develop quite a lot of automated curation. So we're partnering with SIGDA to use their auto scavenger, which is extremely good. And we're plugging in auto monitoring and auto annotation aspects. And I don't have time to go over this, I'm afraid. So I'll come to the end. Skip out. Right. So I guess I will mention this last one. The most important thing for Biocatalogue is it's got content. Because if it hasn't got content, then it's useless. And because the content is there to be annotated. So we're making very sure that we get content by partnering with people. So, for example, we can scrape from various different other sources of service information, but we've got a feed from the SIGDA service, which, as I said, is a large-scale search engine for general web services, and they've opened their API to us. We can feed and cross-link to other key registries like the Biomobi registry, but we've also partnered with people like the Embrace projects and so on to migrate their services, so that we can use all of these things to populate our service registry. And our integration pilot will be with My Experiment in Taverna, so that the Biocatalogue becomes deeply intertwined with My Experiment, so you get a My Experiment tab, a service tab in My Experiment, which is another view over Biocatalogue. And of course, as Dave mentioned here, that we can do workflow analytics, stealing a term from Juliana. That means that we can analyze which services get used by which workflows, which are their popularity, the relationship of services to one another, and so on. And we will replace in the Taverna workflow engine the current service palette for a Biocatalogue palette. Okay. So this is the Biocatalogue team. These are our partners. And this is just an indication, a reflection really, on this is such an obvious thing to do. Why did it take so long to get round to doing it? And I would say that there's been a long time waiting for getting the dedicated resources in order to be able to do it. And other efforts in doing cataloguing of web services have concentrated on doing largely concentrated in the research community anyway, on doing quite complicated, sophisticated descriptions of the function of the service in order to be able to do automated composition. We're not going to go down that route because that's being too damn and unnecessarily clever. In fact, what most people want is something that is a full set of services that they can use that then tells them this service is reliable and this service isn't, and then they can make a decision. And then the person will then incorporate it into their application, and they'll read the documentation. They want the documentation written as words, not as complicated expressions. There's a role for ontological descriptions, but it's not the only thing that we need to do. Okay, so that's the thing. Thank you. Intertwinkled.
That's a new one for me.
No, Intertwinkled is from Ted Nelson. Ted Nelson invented
I like
that.
it. I must start
when he
using that
invented
one.
hypertext, he invented the notion of intertwinkling.
Questions now? We'll go back here first, and then I'll come back up to you.
Well, thank you. I think this is very useful, and I'm going to throw out another quality-related question. As a bioinformatician, I'd say if when I choose different services that, let's say, give me predictions on the regulatory binding side of transcription factors, when there are lots of softwares available, what I really am interested in is not only the speed and reliability, but also the correctness. But the problem is all the tools are somewhat different, and there's a lack of golden standard. So unless you actually spend the time by the true expert who understand this domain well to develop the golden standard to evaluate the tools, and I think the whole field ourselves, we're very confused and then don't know, except to rely on the journal. So I think I really want you to think for us and then find better ways and in-depth maybe evaluation so that we can benefit from this service.
So we're sticking in these, at least these pilot phases, with and the idea is that we go out with the pilot and then we increment, we evolve, we perpetually beta. That's what we do, stealing the previous talk's term. So as we progress, this is the sort of thing that we could investigate. I don't think it's not the core activity. The core activity is first of all find and keep a reliable, sustained collection of that's curated and up-to-date services. And then there's the issue of are these services technically available, which is what we're really focusing on. So because we can automate that, the Embrace directory, for example, insists that you submit test scripts. And so people can see these as examples, and also we can run them over and over again in order to make sure that things are really working, which is not the same as pinging. So seeing if something's alive is different to seeing if it's actually working. So they're supplying gold standards for their own services. And so we're incorporating that in the Biocatalogue as well. But that's slightly different because each service is supplying its personal gold standard about how it should work. What you're looking at is comparisons of the actual algorithms themselves. And that, I wonder if we can use this and use the social networking, social curation ideas that came from my experiment to encourage the community to begin to pool their knowledge about these services using this infrastructure. I don't think we have the either the capability or the resources to systematically go through everybody's algorithms and say, "Whoa, this one's better than that one," or more reliable. And in fact, I wouldn't even dream of it because I would have my arse sued. So there's no way I'm going to do that.
Other questions? Oh, yes, I forgot about you.
Can you give us a 5-millisecond glimpse on what you did not say about annotations because you didn't have time?
Oh, yeah. Well, it was that Duroy chap. He just went on and on at the beginning. And there was no chance to... this model here. So what we had to... is actually... We have very partial annotations and multiple annotations, and the annotations are very polymorphic. So you can have text and statistics and tags and ontologies and so on. And you also, the annotations themselves have annotations. Okay, so, and also we have multiple providers and multiple versions and multiple deployments. So what we have is a very general, the notion of an annotation assertion. So we have a model that allows you to say, okay, I'm asserting that this particular service or object has this annotation, and that annotation could be free text or tagged. And that annotation term, because it's first class, will carry provenance information. Now, Eric will say, that's RDF. And you know what? He's right, but don't tell anyone.
Okay, excellent. Thank you very much.